Hi. Now we've been talking about the atmosphere on and off before our break, and we are still talking about the atmosphere. It's all a part of our weather in the atmosphere, our meteorology sections of Earth science. Now, we know that the main ingredients are nitrogen and oxygen and argon, and a little bit of carbon dioxide and a bunch of other little bitty bits. But we live at the bottom of this thin layer of air that completely surrounds the planet, called our atmosphere. It's kind of like an ocean of air. Now what I need to say is that, do we feel the pressure of living on this ocean of air that's squishing it down on us? That ocean may be somewhere between 60 and 300 miles thick, depending on who you ask. It's kind of hard to measure the exact top of that ocean of air, but we live at the bottom, and that's the thing that's important. Now, we experience about 14.7 pounds per square inch pressing down on us because we have this 100 kilometer high pile of air mushing down on us in all directions. Now, what this demonstration is going to show you is what things experience when they feel that 14.7 pounds per square inch pushing down in all directions. All I have here is a hot plate, and you can tell the steam's rolling out. There's a splash of water in each one of the cans. And all that's doing is the little bit of water that's at the bottom is boiling. And you can see the water vapor coming out of it. And what that also is doing is it's causing the air in the can to get pushed out. And so there's not much air in here. There's only water vapor. What happens if we cool the cans? And that's what we're going to do. Now, the way we're going to do it so it cools it very quickly is I'm going to take a can of boiling splashes of water, and I'm going to put a can in a beaker of water. It's going to do two things. It's going to plug the top of the soda can, and it's going to cool it off very quickly. So all the water vapor that's steaming out is going to shrink back to water droplets, and we're going to prevent the water from the air to fill in the hole in the can. So all we have is the air pressure pushing down without pressure inside the can to push back out with equal forces. And if we do it just right, then the can is crushed very quickly, almost quicker than you can experience. It doesn't matter what size of can you use, hopefully. 14.7 pounds per square inch is a lot. And it should collapse very quickly. That's because there's all the pressure pushing in without equal and opposite pressures pushing out. So the can is squished. Now, a lot of people think, oh, the water is important because the water fills in everything. It should work without water, but it may take a little more time. Now, I'm going to move this one out of the way very quickly because we're going to save that one for later. But I'm going to take this monster can. The reason I like this monster can, I've never tried this before, but it's a much larger can. Can that withstand the pressure? And what we're going to do instead of adding water immediately, as it's cooling, the atmospheric pressure is working on it almost as convincingly as it did in the water. A little bit slower because it's still pretty stinking hot. But the atmospheric pressure is so great that it doesn't have much a chance to resist it. Now what I'm going to do on the next video is we'll ask, is there a limit to how big the can can be before the atmosphere isn't as strong? Thank you. See you later.